Okay, I misspoke on the last video. That is supposed to be 120 degrees. So there you go. And I said root 2. I meant 2 squared, 3 root 2s. I wrote the right thing, I believe, but I misspoke. All right, on to the new stuff. Talking about directions in real life, okay, especially the direction of a vector in a horizontal plane. So we're talking about planes, ships, that sort of thing, generally, usually balloons, maybe. Reference system, and we don't use the standard math notation from the origin counterclockwise from the x-axis. We use true bearings or just bearings. Usually people just say the bearings. And we give a magnitude. There's the magnitude in this case. And then 120 degrees, and it is measured clockwise from north. Clockwise and north. That gives us a true bearing. Okay. Quadrant bearing, or compass headings, often I will say, or people say, compass headings are magnitude, but then it's always referenced from the north-south. So it's either east or west of north or east or west of south. So here we have a displacement vector d, 5 meters, and it is north 45 degrees east, but when you read it, you say east of north. But written, it's north, and then how far east. Okay, if it's 45 degrees, you don't actually have to say that. You can just say northeast. All right. Draw a vector given by magnitude and true bearing, so true bearings. And we're just going to try to keep the magnitude somewhere close to reasonable. So magnitude is 2, so that's the smaller of the two vectors. Different units, different things completely, so that isn't the most important thing, but here you get the relative idea. Here's vector r. It has a magnitude of 2 meters, and it's at 0, 60 degrees. So I'll just note that it's 60 degrees right here. Vector A is 225 degrees. So it goes here, 5 meters per second squared. So it's an acceleration, 225 degrees. And that's measured all the way around here, 225 degrees. Example 10. Example 11. Draw each vector given magnitude and quadrant bearings. So this time they're giving us the bearings. North is, of course, I should have said that maybe. North, south, east, west. I assume you guys know that. D, vector D, is south, 60 degrees towards the east. So south and then 60 degrees towards the east. That's vector D, 2 meters south, 60 degrees east of south, if you like. And finally, we have 10 newtons of force, and it is directly west. So I would draw it this way. Force 10 newtons west, like that. And I think that's it for the lesson. Oh, convert. Convert this to quadrant bearings. You can sketch this quickly. It's this way, right? This will be 30 degrees. So in quadrant bearings, it's still 5 meters per second, but it is south 30 degrees towards the west. This is west, so it's towards the west. And again, sketch it, and it can help you if you're getting stuck. North, 30 degrees to the west. So north and west, this is 30 degrees. So 25 meters. And for a true bearing, it is 360 all the way around, 30 short of that, so 330 degrees. And that's it. Check, I think that's it. All right, that's the end of the videos for 6.1.